Good evening, guys. This is the start of our math university classes, and here we start from Unit 1, Sets, which is a kind of big unit, but they are very useful for your future studying mathematics because many things are represented in sets. Okay, let's get started. And here is our content table. You guys can see that this is including a lot of topics starting from 1.1 definition of set, and all the way we got representation of set, relation of set, all the way we go to Venn diagram 1.8. So we have about 9 courses to detailedly explain everything in this unit. And then so today we're going to start from the first unit, the first chapter, 1.1 definition of set. And let's get started. Definition of set. So as an introductory class, we're gonna start from the definition of set first. So this is the first class is more like an introduction of the whole unit, including a brief explanation of all the topics we're going to include in the following courses, and then have a brief understanding about it. So first of all, a set is a well-defined collection of distinct objects, considering as an object in its own right. The objects in a set are called elements or members of the set. Well, usually we use elements more, so you guys can remember this. So it says that a set is a collection of objects, and there are two very important words here that you guys might have to take notes. So a set is a well-defined collection of distinct objects. Okay, so let's see whether you guys can somehow understand what does this mean. So for example, let's have set A, and then set A includes probably all animals in Earth, on Earth. Then we start from dog, cat, maybe bird, and etc. Okay, so first of all, in this set, we use two curly braces to enclose the elements, and the elements are separated using commas. So the thing is that, first of all, if you want to check whether this set is correct, or say it meets the standard of a set, and then we're going to first have a look at the word well-defined. So set must be well-defined. Let's see what is the definition of this set. It means all animals on Earth. This is a well definition, right? Because by well-defined, we mean that through this definition of the set, we know that what kind of elements will be included and what elements should not be included. It is rather clear about the element's identity in this set, so it means that it is well defined. And then it is a collection of distinct objects. So the point is that distinct objects, it means that the elements should be distinct. There cannot be, for example, we have a set and then we have dog, and then we have dog, I have dog. So a set like this is violating the law, or say its feature of being distinct. Every element inside should be distinct. We can say that there is dog A, dog B, dog C. Then those are distinct because they are not the same dog. But if you only write dog, 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 then it will not be distinct objects, and it will violate the feature, or say characteristic of set. So it will not be defined as a set. Okay, so this is the very basic definition of it. Let's move on to some of its properties, just as I mentioned. Okay, let's have a more deeper understanding about it. So the first property is well-defined. A set must have clear criteria for what is included as an element. For example, the set of all even numbers is well-defined because it follows a specific rule: any number divisible by 2. So even numbers, this is the condition, or say the set's definition, and then it can be defined because it can be explained, and it follows a specific rule. For example, if I say a set of my family members, okay, then we have mom, dad, brother, and me. So this is well defined because my family members just include my mom, my dad, my brother, and me. So guys, you can see that it is well defined because it follows a specific rule that these elements of the set must be a real member in my family. And I have make it clear that it is my family, so it will not make any misunderstanding based on this definition. However, if I have a set of family, what should I put inside? Right? There is a question about what should we put inside if the set is only including family, not my family. So when it only includes this word family as a condition, it is not well defined because we do not know what kind of specific rule will all these elements be following. So that we don't know whose family is it, so we cannot put any elements inside because we don't know what criteria does it have. So it doesn't have a clear definition. It is not well defined, so that it is not a set. Anything that does not satisfy this property of well defined is not a set. Okay, so make sure that in the future, if you want to write a set and when you have to define it, make sure that the definition is clear, or you don't know what to put as elements into the set. And let's go on to the next property of set. So the next property of set is distinct elements. A set cannot have duplicate elements. For instance, the set with elements 1, 2, 3, 4 is equivalent to the set 1, 2, 3 because duplicates are not counted. It means that it's not 1, 2, 3, 4, I mean 1, 2, 2, 3, right? So that when you guys see a set that includes like same elements, the elements that are exactly the same. For example, I said animals in my house. Animals in my house. So assume this is the set, and then I write dog, cat. So what is the problem here? The problem here is that we have two dogs, and these two dogs are exactly the same, so that it violates the law of distinct elements. When I write a set about animals in my house, so this looks like the types of animals. So every type should only be counted once. Even though I have two dogs, I should only put dog and cat, and that is it. So we should not put the same elements inside so that it will be counted twice. It is not how we deal with it. But if you want to show how many exact animals are here in my house, instead of the types of animals in my house, I can write, because for example, my dog is named Bobby, and another dog is named Harley. My cat is named maybe Stella. Okay, so if I want to write the actual animals in my house, we have Bobby, Charlie, and Stella, which is dog 1, dog 2, and cat. So that these are different because even though Bobby and Charlie are both dogs, they don't share the same name. They are not the same dog, right? But if you only want to represent the types of animals in my house, then if you write two dogs, these two dogs will be the same. And then because they look exactly the same, they are the same element, so that those duplicated are not counted. So just make sure that in your future studies, whenever you see that there are duplicated elements in one set, you know that there is a problem because it violates the property of a set. The property's name is distinct elements. And also make sure you remember this well-defined, right? Remember this name of it, well-defined. These two are the properties of set. So after learning about the properties, and then because this is more like a intro class, so the examples will be less than those in the following classes, but we'll go all the way through so that you guys know what is going to be taught in this unit, and then have a brief understanding about it so that when you see it directly in the following courses, you don't feel too difficult or confused. So next we will go on the notation of sets, or to say this is the representation. That is how you represent a set. Representation set. So first of all, we're going to introduce to you three methods. The first method is roster method, or we say it is listing method. So as it is called, it is very easy because we only have to list all the elements. But for example, we have to have a curly brace in the beginning and at the end, and then inside we have different elements A, B, C, D, E, etc. For example, this set is all the alphabets. Set A includes all the alphabets in English, so A, B, C, D, E, F, G, all the way to Z, right? This is our listing method. This is the most simple one because you only have to list everything inside. But as you guys see the example of alphabets, I think you guys somehow know about what is its shortcoming, right? You can see that we cannot list everything of it. Sometimes we have to use dots to make it look shorter because it is very hard to write every element inside one set, like by hand or by typing, so that many times we have we need to use other method to represent the set so that you don't need too much space and time to write it. And those will be less clear than this one, but they will be more convenient and somehow a little bit harder than listing method. Okay, so you guys remember roster method or listing method is simply listing every element here and then just separate it with commas. And then next we're going to move on to set builder method. So set builder method is kind of different from listing method. I can say that. Okay, let's say what kind of sets we want to create. We want to create that maybe. So I'll first explain to you the structure of it. I mean, like how to construct a set with set builder method, and then you guys can try to create one by yourself, right? And here, let's say we have so we have this part. This part is going to define the domain of the elements here. So all the elements must follows or say belongs to a certain domain. That is what you write in the left part of it. And then there will be a vertical bar here to show the separation of domain, and here is what we write of conditions. Domain, the thing is a little bit small. Hope you can read it. This here is condition. So, okay, so what does this mean? If we have an example of something, for example, create a set that includes all the natural numbers less than 10. Okay, so this is a set of all natural numbers smaller than. Okay, so here let's see what is the domain of X. Let's say we use X. So X belongs to a certain domain. This is a symbol that I'll teach you later, so it somehow means belongs. And then we have a domain of natural numbers, right? So this is domain that limits like every element in this set must belongs to this domain. So the domain is natural numbers, and its symbol is a capitalized N. And then we have a condition, right? The condition is here. So the thing is that it is smaller than 10. This condition can also be a domain, but we usually don't put it here. Usually we'll put if there are any domains for like integers, natural numbers, kind of stuff, or prime numbers, even numbers, we usually put it here in the domain. But if it is just simply describing x should be smaller than something, or bigger than something, or between something and something, we usually put it in the condition part. So first of all, we have in domain here, x belongs to natural numbers. And then in condition part, we write x is smaller than 0. So this is how you construct a set that represents all natural numbers smaller than 10 in set builder method. You can somehow realize that you don't really have to write everything by yourself. You don't have to write 1, 2, 3, 4, 5, 6, 7, 8, 9 as in roster or listing method. You can only create this with a domain in the left and a condition on the right. And in the middle of it, you put a vertical bar to show the separation. So this is how you use a set builder method. And somehow you guys can see that the same set can always be represented in different forms. For example, this alphabet set can also be represented in set builder method. So a set of all alphabetic numbers might be a set of, so x, it doesn't really have a domain because this domain part usually serves for as in math. So even though a set of like letters is also a thing in math, but it doesn't really follow some kind of mathematical rules because it is just alphabet. So it is not a domain here. We don't usually say that when x belongs to an alphabet, we usually don't think this is a domain. We usually think this is a condition. So x is a letter in alphabet. Okay, let's just use x is a letter in alphabet. So this is exactly the same thing as set A here. Okay, so these two, they are different methods of representation, but eventually the sets here they represented are the same thing. And some of you might think a question about what about the order? So what about if I write it like E, B, F, Z, A, like this? We still include all the elements inside. So is this still satisfying the condition of it? Is this still satisfying a set of all the alphabets? Actually, yes. So I have to tell you that even though the order is changed, it doesn't mean that this is another set. So another property, or say we don't usually say a property, but a feature of set is that the order does not matter. So either you write A, B, C, D in the traditional order, or you just mix it up and like E, B, F, Z, A, C, D, maybe O and L, P, M. This doesn't really matter. It doesn't really matter if you change the order of the elements. Well, as long as it is well defined and you have distinct elements, so you don't appear to be two A's or two B's here, then it is still a clearly defined set. And also it is the same set with the set that has same elements but different order. Okay, so this equals to this, and this also equals to this. So, and this also equals to this. Basically, these are the same thing. These three, this one, and this one, they are the same thing, just in different methods of representation. And then we have interval method. Interval method is when you use an interval to show it. So the space here is rather small. I think you guys can still see it. So an interval is combined of two endpoints. So the word interval is usually represented on the number line. So I think you guys all know what's the number line, right? Let's say here is 0, here is -1, -2, -3. And then we have 1, 2, 3. So whenever you create an interval, you have two endpoints, right? So it means that you include all the numbers between these two endpoints. It means that, for example, I want to include all the numbers between -1 and 2. So this rectangle, as I just colored, is a interval from -1 to 2. So I include every numbers inside these. Okay, so and later I will show you in the following course that specifically talks about the representation of sets. I will teach you more about how to represent it using interval method and how many types of intervals we have and stuff. Okay, so I think basically just briefly introduce what methods we have so you guys can have a very basic comprehension of it. You guys can now know that we have roster method, or called listing method, and we have set builder method, and we have interval method. Okay, and then after this we're going to enter about the types of sets. So after defining the sets, after letting you know how to represent the sets, you guys have to know how many types of sets there are. Okay, how many types of clearly defined collection of distinct elements are here. Okay, let's take a look at the next slide here. Okay, so here, as you guys can see, we have 5 types of sets. So this is very clearly classified, and they are all different. So first of all, we have empty set. Empty set is a very easy concept. It's very easy to understand because an empty set is a set that contains no elements. So basically it just means that in this set there are no elements inside. So how do we write it? We still use the curly braces but nothing inside. Or we can use another symbol for it. This. So it is a circle with a bar on it, a bar that pointing on this direction. And basically this is what is empty set. It is called empty set because it is empty. It has nothing inside, it has no elements. So let's say for an example, if I have a set that asks me to list all the prime numbers. You guys know what is prime numbers, right? Maybe I'll just choose to use another example. Let's say list all positive numbers smaller than 0. So all positive numbers that are smaller than 0. So the thing is that you can still create a set of all positive numbers smaller than 0, although there are no positive numbers smaller than 0. So it means that no elements can actually satisfy this condition, but it doesn't mean that this set does not exist. This set still exists, but it is empty. So that is more like a property of empty set. So you guys have to know that it is not meaningless. It sometimes can represent kind of a fact or represent what set it is. For example, in later we will talk about intersection and union, which is not mentioned now, but in later courses you might know what does empty set can do. So if you want to write a set of all positive numbers that are smaller than 0, you don't have any positive numbers smaller than 0, so that it is an empty set. You use this two curly braces with no elements, or you use this symbol. Okay, and then we have finite sets. So mostly they are just defined by the names. If a set is finite, it means that it has finite number of elements. Well, it is very possible that for some sets there are infinite numbers inside it, because there are infinite numbers of elements that satisfies its definition or its condition. Well, for finite set, it has finite number of elements, so that, for example, if I want to have a set of all the integers smaller than 5, then we have 1, 2, 3, 4, right? All the integers smaller than 5, and bigger than 0. All the integers smaller than 5. Okay. Where's the eraser of this? So bigger than 0 but smaller than 5. All integers. So this set satisfying this condition has finite number of elements. So 1, 2, 3, 4, right? We have 4 elements. This is finite number, not infinite. So this one is a very classic, very typical example of finite sets. While on the opposite, we have infinite sets. So this is something that's the opposite, has infinite number of elements. For example, if I want to create a set of all positive numbers, so let's say we're going to start from 1, 2, 3, 4, 5, all the way to maybe positive infinity, right? Because we cannot really represent an infinite set with roster method, as I just write everything inside the curly brace. This is called roster method, and then it is usually not used here. It is not usually not available for infinite sets because there are infinite numbers of elements. So for infinite sets, we usually use a set builder method, and sometimes we may use interval method, but we rarely use roster method. So this is one example that a set has infinite number of elements because there are infinite numbers of elements that satisfies the condition or the definition of the set. And then we have subset. A subset happens when this set, all elements, this set belongs to, I won't say belongs, I'll say is, oh wait, I have to use R, but is all elements in this set are elements of another set. What does this mean? It means that, for example, we have set A here. Let's put here, set A, and set A we have 1, 2, 3. That is its elements, and then we have set B that has 1, 2, 3, 4, 5. So you can see that all the elements in A, 1, 2, 3, are also elements of another set, of set B, because B also include 1, 2, 3. So in this kind of situation, we will say that set A is a subset, because sub means smaller, right? Belongs to, so subset of B. So now A is a subset of B. All elements in A are elements in B. So this is how you understand subset. And then we have universal set. So universal set, which is denoted as U, this is a symbol. It is called universal set because it has a property that it includes all the possible elements inside one specific or certain context. So for example, here we have a set of all positive numbers starting from 1 all the way to infinity, and this, or I might say, is all positive integers. So this is one kind of universal set because in this set it has every number that satisfies one context or one specific condition of, for example, all positive integers. Or I can give another example of having a universal set of all fruits, and then if there are actually every fruit inside the on Earth, and then it is all these fruits are elements of this set, then this set is called a universal set, and it is a universal set of fruits. Okay, so you don't whenever you want to create a universal set, you usually still don't use a roster method because there is no way that you can write everything in a set. You can write every element by yourself, and because there are sometimes, even though it's not infinite, it's not that much like infinite set, but there are huge numbers of elements, and you cannot write it by hand. So you usually will use set theory method, because in set theory method, it is more convenient to include more elements that satisfies the same condition. And so if in a very specific context, for example, fruits, and this set actually have every fruits inside it as elements, it is called a universal set. So remember the name of these 5, and especially universal, because you can know what does it mean by its name. If sometimes you forget about it, you can think of universal, universe, right? It contains everything, so that eventually you're gonna realize what does this mean. When you sometimes maybe need it in a test or in an exam, quiz, or solving real life problems. And then we're going to talk about notations of sets. So this is not about representation, it means notations. So these notations are mostly symbols that you guys have to memorize, because in a later calculation, or say when solving problem, you cannot write everything in English words, right? So you have to learn about the symbols, just like addition mark, subtraction mark, kind of stuff. So this is a very crucial topic of this unit. And let's see, we have a lot of notations that we have to remember. First of all, we have this one that I have used before. It looks like an E. So this E means is an element of. So it means that, for example, we have something here. We have A is an element of a set. And this D here should be a set. So an element is an element of a set. That is how it is used. So let's see the examples. 2 is an element of this set including 1, 2, 3, 4, because it includes 2. So 2 is an element of it, right? And for example, apple is an element of universal set of fruits, kind of stuff. This is how it is used. And this is maybe the most frequently thing you're going to use in the future. It's an element of. And then on the opposite, we have a bar based on this is an element of. So just as like in equal is this equation mark, and then unequal or not equal to is this mark with a bar. The same thing happens here. If you want to say 2 is not an element of this set, including 1, 3, 5, then you just write this the previous notation mark, but with a bar on it. Okay, so now it happens when this element is not included in this set. We say that this element is not an element of the set. And then here we have union and intersection. That is what I said that I will talk about later. Well, here we only talk about its notation marks, how do we write it, but in the future we're gonna talk about its properties and its applications, kind of stuff. Okay, so the union of set, it means that in set A, let's say this one is set A, this is set B. So the union of a set A and set B, it means that in this new set, because if they gets united here in a union, it will form a new set. So in the new set, all the elements in the previous set A and set B will be included. But let's say, look at this. Why is it 1, 2, 3, 4, 8 and not 1, 2, 3, 3, 4, 8? Start thinking about the properties that we have talked before, right? So one of the properties of set is distinct elements. So that is because in one set, you don't really have to write 2 3s, like 1 3 can already include it. And because in the sets, we don't include the 2 elements that are exactly the same. So here we will not count one of the 3s because it's duplicated. So in the union set, we only have 1, 2, 3, 4, 8 instead of 2 3s. Okay, so in the union of set, it will include all the non-duplicated elements of the previous two sets. So it is a combination of two sets. And then if we have union, then we have I won't say the opposite of it, but somehow it is quite different. And the symbol is the opposite. So this one looks like a U, then this one looks like a N. So this is what we call cup. And this is what we call cap. But it doesn't really matter. You only have to know why is it like this, then it's fine. So you can see that in intersection of set is totally different from union of set, because in intersection of set, 1, 2, 3, and 3, 4, 8, only 3 is included in the new set. That is because intersection, as it is meant to be intersection, it means that only the common elements inside the previous two sets will be remain. So that only 3 that appeared in both set A and set B will be remain here in the new set of intersection. And those who are not repeatedly counted, because they are not overlapping to each other, so the other elements will not be included in the new set of intersection. So that is intersection, that is how it works. And then here we can see that that is what we talked before, the types of sets. So this U pointing rightward, it means the subset of set. So it means that when all the elements in set A are also an element in set B, then set A is an element of is an subset of set B. So this is the symbol using a U that points rightward. So we have a U pointing upward, downward, rightward, and leftward. So the last one is superset of set, which is somehow a thing that we rarely use. You don't have to pay too much attention to it because we usually use subset of set because they're basically the same thing but just changing the order. So here you can see that if A is a subset of B, then B is a superset of A. So that if so this is the other way to say subset, just like because if all elements in A are also an element in B, then A is a subset of B, and also B is a superset of A. That is like the opposite relationship, as they really mean the same thing, but just changing the way to say it. We usually still use a subset of set instead of superset of set. And the last, adding a bar here, just like the ones in is not an element of. Adding a bar to the symbol, the notation mark of subset, means that it is not a subset of set B or another set. So here you can see that as in set A, we have elements 10, 12, 20, and 30. And in set B, we have 1, 2, 4, 8. It is very clear that set A is not a subset of set B. So this is how you use it. You use a U that looks exactly like a subset, and then you put a bar on it, showing that it is not a subset. And the last, that is what we have told before in the types of sets. So empty set is denoted as a circle with a bar on it, or 2 curly braces with no elements inside. So those are the notations of it, of sets, and that is basically including all the notations you will need to know, you need to use in this unit. So you guys might take a shot screen of this photo of this graph, and then you guys have to memorize it because this is very important. If in the future questions or exams you look at this maybe union and then you misunderstood it as intersection, you will get your whole answer wrong. So just make sure that we remember every single one of it. And that is basically the end of our class. I hope you guys have a basic understanding of sets already. And then in the future courses, we're gonna go through deeper in each topic, in each concept. So make it very detailed, and then we have practice questions kind of stuff. So this is a very intro class of the whole unit, and I hope it's not too hard for you because they are basically easy concepts and we will not go too deep. So we'll explain it very detailedly, but not using it in too hard real life problems kind of stuff. So if you guys all understand, then this is the end of the class. If you want to review some of the informations or say content of the class, just go back to where it belongs and watch it again. Okay. So goodbye, guys. We don't have homework for this class. And then let's see you guys on the next class.